Java Fundamentals Part 2. What we're going to do now is continue along the path of learning the core fundamental concepts of Java. And what we're going to focus in on now are working with variables and data types. So the first thing we have to kind of get under our belt is understanding the concept of a data type. There's a couple of things to be concerned about in terms of what you need to know about working with Java data types. And once we understand the data types and what's available to us, then what we have to do is learn how to declare variables. And when we're declaring variables, we can do some pretty cool things with them. And that will get into how we use operators and assignments. Where we declare the variables inside of our files determines its scope. You could also think of scope as like accessibility or access. So we'll talk a little bit about variable scope. And Java has tons of keywords and access modifiers. Well, how do they affect variables? What if I make a variable private or public? What does that do? Then we get into a pretty cool conversation talking about casting and conversion. This is where you could declare a variable type of one thing and actually have it convert into another type. Now, when it comes to working with data types, a couple of things you have to worry about, or think about rather, is Java has what are called really basically two types of data types. There's two categories. What we're going to focus in on now are called the primitive data types. And primitive data types, the word primitive means that they cannot be broken down any further. Some data types, specifically these user-defined ones, which we will be spending the majority of our time talking about later on, are made up of other data types. They're composites, but primitive data types can no longer be broken down. They are the base. They are the core. I like to think of primitive data types as kind of like the elements on a periodic table. Remember chemistry? Oh gosh, I hope I'm not bringing back any like horrible chemistry nightmares. But you take something like, oh, hydrogen and oxygen. Hydrogen cannot be broken down into anything else, nor can oxygen. Oxygen is just oxygen. Hydrogen is just hydrogen. But obviously, when you put them together, you get water. So water can be broken down. Uh, just helium cannot be broken down. It is just helium. Just like with these primitive data types, they cannot be broken down anymore. And Java gives us 8 primitive data types. Let me just also make another note too. Some of you might be considering to go out and get the certification for this, for Java, the Java 2 certification, maybe like the Certified Java Developer or Certified Java Programmer. You're going to have to memorize the data types and ranges and values and all sorts of stuff. Now, that might sound a little scary right now, but I'm going to show you some things to help you remember those along the way. So what data types are available to me as a Java programmer? Well, let's hop out to the java.sun.com website. As I told you, one of my goals is for you to become very familiar with that. And what you understand is that the data type really starts to determine the values of our variables, okay? And we have to make sure that we're assigning the correct variables to the right data type. Let me mention to you also that Java is what's called a strongly typed programming language. No, that does not mean you bang and type on the keyboard harder than you would a loosely typed programming language like Visual Basic Script. What it means is that you must be declaring and working with the correct data types. That's really important because typed or strongly typed programming languages are safer. They're not prone to generating errors because you are in control of the data types, and therefore you're in control of the accuracy of your calculations. So let's take a look at this. A couple of things that you need to kind of keep in the forefront of your mind when we're going over data types is, what is the data type's name or the keyword used to define that type? What is it all about? And what is the size? Okay, and I'm going to review this with you a little bit later on. A byte. A byte is the smallest data type available. As you can see, it's 8 bits, so it's very, very small. That means it's represented by some permutation, some combination of 8 ones, or zeros. Okay. Now I'm going to go over the range of these in a little bit, but let me just introduce you to the primitive data types. The short is a little bit larger. It's 16 bits. The int is used for integer variables, and that's 32 bits. And the long is for long integers, and that's why you'll see it's really big. It's 64 bits. Now, these are the integers. These are the integers. But what about real numbers? Well, then sun gives me float and double. And basically, the difference between a float and a double, am I using single precision floating points, like decimals, or double precision? Now, a single character, a Unicode character, is a 16-bit long data type called a char, otherwise pronounced char. That's open for debate. I'm more of a char kind of a guy. Don't know why, but that's where I landed on that one. Now, Boolean. This is your true, false. Something for you C developers out there. In Java, a Boolean can only be the literal word true or the literal word false. Notice no quotes. It cannot be a 1 or a 0 or anything like that. But what about the ranges of these data types? Well, let's check out the ranges. Here I've kind of bookmarked already the data type links that I wanted to kind of go over. And here we can see the ranges. And we can see a little bit differently how the data types are presented to us again. Here we can see that we have integer types and floating point or decimal types. Those are the main types. So we have 1, 2, 3, 4, 5, 6. But what about the other two? There are 8 primitives. Well, characters or char, or cars, I like to pronounce it, that doesn't have a range, okay? It's not a negative or positive. It's Unicode characters. And Boolean is just true or false. So here you can see the 8-bit or single byte data type. Well, that would take a few seconds to think about. Ranges from negative 128 to 127. So a byte is good for working with small numbers. If I need a little bit larger of a number, maybe I'll use a short or short integer. You can see it's from negative 32,000 to 768 to 32,767. If I need large numbers, you can see I'll go with an int. And even larger, I'll go with a long. Now, I want to point out, because again, as I mentioned, some of you might be interested in taking the Java certification exams. And the certified programmer exam is the exam where you have to know the nuts and the bolts of Java. This is the introductory exam, and you have to memorize just all sorts of wacky stuff. So what you first have to understand is you have to memorize, obviously, the 8 primitives. Here we're just looking at the numeric ones, so we're looking at the 6 numeric primitives, and the sizes. But you also have to memorize the range. And here's what you can see, and I'll show you this a little bit again later on when I show you it in a different format, but notice how the range, these are signed, okay? Signed meaning they are positive or negative, and that the negative is always a little bit greater than, in terms of the last digit here, it's 1 greater than the last. So notice we have an 8, negative 128 to positive 127. So 8, 7. Look at this, 32,768, 767. See? It's always minus 1. Negative 2,147,483,648. Blah, 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 647. And look this one, negative 9, da, 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 8 to positive 9, da, 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 7. Okay, so that is a pattern that I want you to kind of gleam onto. And I'll show you that in a different format coming up. Okay, so now that we know the data types, let's talk about declaring variables. There's a couple of things that you need to pay attention to, be aware of. When declaring variables, you have to ask yourself a really important question. And no, it's not, do I feel lucky punk? It's, where am I declaring the variable? There's basically 2 places you can declare a variable. Inside of a class or inside of a method. Those are the only 2 places. So if I'm declaring inside of a class, there are some rules that apply. First of all, if I'm declaring a variable in a class, you might see that simply referred to as a field. That variable becomes a field. And it is initialized with the default value of that data type. So a default value of an int is 0. As a matter of fact, default values of all the numeric data types are 0. The default value of a Boolean is false. Okay, so you want to know that. What if I declare a variable in a method? Then what happens? Well, that in the literature is simply referred to as a variable, or if you have some kind of a programming background, you might know that as a local variable. It's only visible within that method. So therefore, it is said to have method scope, and you have to give it a default value because they are not automatically assigned with the default values. They're not automatically initialized to default values. Okay, so now that we've kind of checked this out a little bit, let's crack into some Java and demonstrate some things for you. To begin, let me go ahead and open up Notepad. So I'm going to go to my run, and I'm going to type Notepad. I already had it in there, so I'll bring that up. And I'm going to save this file as demo1 in my fundamentals 2 directory. Notice how I save it in quotes because demo1.java. If I don't save it in quotes, what's going to happen is Notepad is going to put a .txt to it, and then it will become demo1.java.txt. So putting it in quotes prevents that from happening. And let's go ahead and create our public class. If you recall, the name of this file is called the compilation unit. And it has to be named, in terms of the file name, it has to be named case sensitively according to the name of the public class. That is why the name of the file is capital D demo1.java and the public class is demo1. All right, so I open up the curly braces. What I want to do now is public static void main string. Let me make sure that's a capital S. String args. This is rote memorization right here, okay? You always want to make sure that you know how to do this. This is the most fundamental Java application you can write. It is one class, one public class with public static void main string args. This whole deal here really should become rote memorization to you. And as we go on, it'll make more and more sense. Obviously, you can name the class other things, okay? Now, before we continue declaring variables, let's take a look at a couple of rules that we have to understand in order to declare variables. Syntax rules I want to just kind of be clear with you on and go over before we start naming things. When declaring variables, the syntax rules that you need to know are few and easy, nothing to worry about, is you cannot declare variables that have white space in them, okay? So nothing like, you know, my space, be with a slash in it as a space. Nothing like my dog, okay? Can't do it. That would become either something like my dog or my dog, depending on your preference. It is case sensitive. So a variable x, you know, capital X, is different than lowercase x, case sensitive. Be careful. And you have to start with a letter, an underscore, that is an underscore, or a $sign. You cannot have a variable that starts with a number, so nothing like my, or number 1, my dog, won't work, or something like exclamation mark, my dog. Okay, not allowed, not going to happen. So now that we have the basic rules under our hand here, let's go ahead and actually try declaring some variables. All right, so let's jump back into TextPad. So remember, we've got two places we can declare variables. I can declare variables at the class level, and they become fields. Okay, and we've got some rules that we'll go over there. Or I can go ahead and declare variables in the in methods, and they become local variables. All right, let's declare a variable here. So I'm going to say public. I like to tab in just a little bit. Tab that in. I'm really picky about how things line up. Public static int my age. All right, a lot of stuff going on here. First of all, we have an access modifier, public. We have a key term static. We have another key term. This is the data type. This is where I want you to focus in on right now. The fact that it is an int. It's a integer, okay? 32-bit int. The name of the variable, my age. Let's kind of play around with that for right now. So let me jump into my command prompt and let me go into my Java fundamentals 2 directory. And let me do a Java C for compile demo1.java. Compile that up and see what we get. Now, remember, with the compiler, no news is good news, so we're doing pretty good. Now, if you remember, I said there were some rules about naming your variables. For example, you couldn't have white space. This is wrong. So I'm going to save this, and I'm going to compile that. And let's see what error message we get here. Okay, what you get here is it's saying, hey, I'm expecting a semicolon because this to me looks like the end of a Java expression, a Java line. Unfortunately, the compiler isn't, that smart enough to go, hey, buddy, it looks like you're declaring a variable here, and it looks like there's a white space there, so fix the white space. No, it just kind of carrots or points to where it thinks the error is, and then it goes ahead and puts the correction there, what it thinks is. And in actuality, it's just bringing that back here. Something else I said it could start with an underscore or a $sign. So let's try putting an underscore there and see if we compile. In actuality, just so you know, a lot of programming languages, including C#, allow you to precede your variable names with an underscore. That is an old standard way of declaring variables. It's a standard that you should declare your class level or member variable or fields, and there's 50 terms for this stuff, preceded with an underscore. What about a number? Remember I said that you can't start it with a number, like number 1 underscore? Whoops, cancel that. So what I'm going to do is I'm going to put that number 1 right in the variable name, and let's go ahead and compile that again. Oh, cannot do it. Why? Now here, it's pointing to an identifier error, and it is showing you number 1. So it is smart enough to figure that out. So let's go ahead and get rid of that. Now, let me focus in on really quick here some of these terms here. What does public mean? Public, if you remember, is an access modifier. And that access modifier means different things based on the feature of Java that you're using. Here we're using the feature of fields or class level or member variables. When I attach public to it, that means I am marking that variable accessible from any other class. Basically, it is wide open. I could, if I want, go ahead and declare something like private, if I could spell that, private static Boolean is funny, okay? Here, private means that it's only accessible within the class, There's another one, protected static shorty. I had a creative lapse here. What does protected mean here? Protected means that it's accessible from within this class itself or the same package or subclasses. Now that's a mouthful. You don't really understand packages or subclasses yet, but you will later on when we go over class inheritance. So let's just kind of stick with the public right now. Now, what does static mean here? Static at this point means this. I do not require an instance of the demo1 class in order to have access to this variable. It's ready to use, okay? I don't need a unique instance to it. Something else. Notice how I didn't initialize my age to a certain value? Now what I want to do is go ahead and print this out. So system.out.println my age. All right, I'm going to save that up. I could do a Control S or save that up. Let's go back to my command prompt here. Compile it, Java C for the compiler, demo1.java. Okay, if that comes back, good. No news is good news. And we go ahead and run demo1. And you can see it prints out 0. Why does it print out 0? Well, it prints out 0 because I declared that variable at the class level, which means it is automatically initialized to that data type's default value. All right, let's continue playing around with this, and let me show you a little bit about operators and assignment. So I'm going to create another variable here, and I'm going to create a variable called public static int my int 1. And I'm going to say my int 1 equals 12. This is a perfectly legal identifier. It starts with a letter, an underscore, or a dollar, either one, and it can contain a numeric. It can't start with a numeric. So now I'm going to go ahead and print out the value of that variable. So system.out.println, and I'm going to say my int 1. Notice that I've assigned it using the single equal sign. And the single equal sign is the assignment character or the assignment operator specifically in Java. So I go ahead and say that's 12. I save this. Go back to my command prompt here, compile it, Java C, and oh, what did I do here? Case sensitive. Thought I was holding down Shift here, so save that up and recompile it, demo1, and no news is good news, and we run it. So I compile that up here, and let me shift that guy over. Now we can see 0 and 12. Let me move my command window up like this a little bit so we could just see this next to each other. So system.out.println my age of 0. I'm getting the 0 because at the class level, okay, when I declare a variable at the class level and I don't assign it an initial value, then the compiler says, well, I'll put in the default value. If I declare it inside of a method, which I'm going to do here momentarily, then what I have to do is assign it a default value. Now here, my int 1, I assigned with an initial value of 12, so that's why it's printing 12. Let me kind of continue along that path and show you another demonstration. So I'm going to do a public static boolean is funny. And I'm not going to assign it an initial value. And I'm going to do a system.out.println is funny. Notice again, I've assigned it at the class level, so it's technically a field. So let me save this. And Java C to compile. And Java to run. And check it out. False. It's false because I have not initialized is funny with a value. If I come into the code here and I specify that to true, notice I do not use quotes. This isn't a string. We're going to talk about literal strings later on. Let me save that and I will recompile and then we'll go ahead and run it. Okay, notice now it's saying true because I assigned the value to true. So again, if I declare a variable at the class level means up here at the top, right after class declaration. So let me say this is kind of like begin class, and this here is end class. Okay, anything inside of here is going to be a field. Now, anything inside of here is a method. So let's go ahead and kind of experiment with declaring variables inside methods next. Okay, so let me move this down a little bit. As a matter of fact, I'm going to kind of get rid of all this junk for right now. All right, I'm going to declare a variable int integer my int, whoops, 2. And then what I'm going to do is I'm going to try and use it. System dot out dot println my int 2. Now notice I just cleared the variable. I did not initialize it. Okay, so I save it, and let's go ahead and compile it. So Java C demo1.java, and oh, look at this, might not have been initialized. That is a great error. This is actually a time when the compiler actually is telling me the right thing. So let me comment that out, and I'll say won't compile because my int2 is not initialized. All right, so now I'm going to go ahead and reuse it here, and I'm going to say int my int2 equals 4. So we'll go ahead and compile it. So I'll java c demo1.java, and it compiles, and I'll run it with a demo1, and we can see I have 4. Why do I have 4 printing? Because I initialized my int2 4. So remember, if I'm out in the class level, I do not need to initialize, but once I'm inside of a variable, I do need to initialize. Now you may have heard me mention the O word, if you will, a couple of times. This equal sign is an operator, and it is called an assignment operator. And there are various types of operators within the Java language. And here again, I'm going to java.sun.com, your soon-to-be best friend. And let's see what type of operators we have. We have arithmetic operators. And those let us do things like add number or subtract. So we have a plus sign, a minus. We have a multiplication. We have a division, okay, and then we have what's called modulus, and that basically gives you the remainder. We have increment and decrement, and we're going to become intimate with these when we use for loops, but basically 2 pluses increments. And what's interesting about the increment and decrement is you could put them at the postfix or the prefix of your variable. Check it out. If I put the plus plus at the postfix or attach it to the end of the variable, it increments OP by 1 and then evaluates the value before it was incremented. If it's placed here in the prefix, it's evaluated to the value of OP after the increment or the decrement. So it's basically when is the value being determined, before or after. We'll play around with that later on. Here we can just have some other arithmetic operator, plus and minus, simple. This is making it a positive number or negative number. Just so you know, you don't have to specify positive. Everything is positive unless you openly say, hey, this is negative. We have relational, okay, and these are conditional operators. Is it greater than this, less than or equal to? Here's the thing that I want to point out for right now. The double equal sign is not assignment, but it's basically asking, in this example, hey, is the variable op1 and op2 equal? So it's used to determine if 2 integers are equal, let's say. This is not equal. These are logical operators, okay, like and or, not. Here, op and op2 with one and, both have to be conditionally true, and we'll mess around with this when we get into some a little bit more logic. I'm just giving you a summary of the various types of operators you have available to you. Here are some bitwise operators for you. Shifts bits, okay, by certain values, and then we have some legal functional and operands, again, some more bitwise stuff. Here are assignment operators, and there's a ton of them because there's shortcuts to them. So plus equals means A plus equals B means A equals A plus B. So let's go ahead and kind of play around with some of this stuff. So let's go back into, let's create a new class here, and we'll start messing around with some of these different operators. All right, so I'm going to open up a new notepad. So start run, and let's get notepad going. And I'm just going to create a new public class called demo2. And this hopefully will become a exercise and rote memorization for you shortly. Public static void main string args. Now eventually you will know what all of this means. But for right now, you just know that this is a template for creating the basic Java application. And remember, the name of the public class is demo2 case sensitively, so I'm going to save this as demo2.java case sensitively. All right, let's declare a variable. Int a equals 5, and int b equals 6, and int c equals a plus b. Let's go ahead and see system.out.println if Java can add. That would be a pretty cool feat, wouldn't it? So I'll bring up my command prompt and go into my Java directory. cd /java and fundamentals 2. Clear that up, and Java compile demo2.java. And let me move. Ooh, oh, it compiled. That's a little scary, huh? And let's see what we get when we run it. So Java demo2. Hey, 6 and 5 is, in fact, 11. All right, so Java can add. So here I use the addition operator, which is an arithmetic operator. All right, so that is addition. How about int d equals b minus a? And I will put d there. Save that up, and we'll see if Java can go ahead and subtract. So I will compile that, and we'll run it, and in fact 6 minus 5 is 1. It makes pretty good sense what I'm doing here, I think. What about some other operators? There was the operator called those compound operators, or those, I've kind of called them shortcut operators, where you've seen them of plus equal, minus equal, things like that. They're compound assignment operators because they're doing an arithmetic and assignment. For example, I could do this the long way. I could say a equals a plus 5. Okay? I could say a equals a plus 5, and then we could go ahead and print out a. So let's see what printing out a here would equal. So I'll save that, and I will compile that, and we'll run it. So you can see I have 10. See, a equals 5, then I come down here and I say a equals a, up here it's 5, plus 5 is 10. Well, that's kind of a long way of doing compound assignments. So let me give you a note here. I'll say long way of doing compound assignment. Let's do the shortcut. A plus equals 5. This is the same thing as saying a equals a plus 5. It's the exact same thing. Let me save, and let's compile. And then let's run it up. Where are you? You're in here somewhere. There we go. And I get 10. Now, those are, that can also work with something like multiplication. So A equals A times 5. Save that, compile, and we'll go ahead and run that. Okay, now I'm getting 25. Well, again, that's the long way, because what I could also come down and do, which is the same thing here, is say A times equals 5. And this is, again, is using the shortcut or compound assignment operator. So let me save that, and we'll compile it and then run it, and I still get 25. So fairly straightforward using those operators. We'll have a lot more practice with them during the rest of the series. All right, the last thing I want to talk to you about for right now is casting and conversions. And this is where you have to kind of understand what's going on with the data types. Because here's what's happening. Byte, short, int, long, float, double, these data types are increasing in size. Notice the bits, okay, are going up as I move along. And what I can do is I can take a smaller data type and put it inside of a larger data type. It doesn't really matter. Let me give you an example of that. Let me bring up a blank slide here. Here's what I mean. A byte, the data type byte, is 8 bits. So that means it's 1, 2, 3, 4, 5, 6, 7, 8. Some combination of zeros and ones, okay? 8 bits. A short, if we go back to the chart here, so let's go back to our casting chart. A short is 16. Okay, so let me go back to my example. So if I go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, okay, which is a short here, you can see that for the first 8 bits, a short will cover it. So I can easily take something that's smaller and stick it into something that's bigger. Here is a small box, if you will. Okay, I can put that small box into this huge box. Okay, it can go inside of here. Can I go the other way around? Can I take something that's 16 bits and shove it into a data type that only holds 8 bits? I cannot. Actually, and this is where it gets weird, I can, but I get what are called unpredictable results. Let me demonstrate. All right, I'm going to begin by going ahead and launching Notepad to create another file. So public class, we'll call this one demo3. Open that up, and here's my signature, public static void main string, make sure that's a capital S, args. And watch what I'm going to do, because there's implicit conversions and explicit conversions. So, for example, I can declare a short s. And remember, shorts are 16 bits long. Then what I can do is I can declare, let's say its value is 32,767. All right. Then what I can do is I can declare an int I, and remember, an int I is 32 bits long, and I can stick s inside of it. And I can then go ahead and do a system.out.println of I, rather. All right, let's see what happens here. Let me save this, and I'll call this quote demo demo3.java. And let's bring up my command prompt. So go into CMD. So I'm going to compile Java C demo3.java. And, ooh, it compiled. No problem. Let's run it. Java demo3. And I get 32,767. No problems. Now that's implicit, okay? As a matter of fact, if I want, I could take that a step further, and I can do like a double D equals I. And we can print D. So I'm going to save that, and I will compile it, and then we'll run it, and I still get 32,767. Now notice D I've introduced as a floating point now, so that's why I get the point, okay, the single precision floating point. All right, so that is doing implicit. These are all examples of implicit conversions. Implicit conversions. No problem here. All right, now let's start getting into some explicit stuff. So to do that, I'm going to create another class file. All right, what I'll do is I'll create demo4. So go into Notepad, and let's bring up demo4 here. All right, so let me go ahead and create Notepad, open up Notepad, and we'll create demo4. So public class demo4, and get my signature. And we are good to go. Save this off as demo4.java. All right, now these are going to be some examples of explicit, meaning it requires what's called a cast. And basically what I'm going to do is I'm going to take something that's of a longer number of bits and shove it into something that holds less bits. Now, the data type doesn't dynamically say, oh, I'll take the more bits. What happens is you get some weird stuff. So let's take an example. Here I'm going to say short s equals, oh, we'll use that 32,767. Okay, no problem. Now watch this. Byte b equals s. And let's do a system.out.println of b. Okay, and now we see some funky stuff. Now, what we're going to notice first is we should get an error. So javac demo4.java. And what's happening is we're getting a warning. It's saying we're going to have a loss of precision, meaning the loss of precision is this. You declared a variable of type short, and you are allowing yourself and saying, I want to use 16 bits to represent my data. I need precision to 16 bits. Now what I'm doing is I'm cutting that in half by shoving it into a byte. Now what I have to do is I have to tell the compiler by overriding it with this syntax. I use parentheses and I type the name of the data type that I want to shorten it down to. And this is explicitly saying, look, compiler, I know I am going to lose some precision here, but I'm going to take the hit. Notice it compiled. Now, here's where it gets funny. Java demo 4. Well, let's see the value here. Let me scoot this up. And you can see I get -1. So we start to get some weird kind of values going on. Now, it actually will make sense to you, and I'll explain to you how we're getting these values here in a little bit. Let me do another example. So let's go ahead and I'm going to take int I equals 100 and byte b1 equals, and I'm going to cast it back to a byte, I. And I'm going to print b1. So I'm going to go from 100 down. Let's see what happens here. So I compile it, javac demo4.java. Right, it should compile. Oh, did I forget a semicolon? Getting a little excited here. So I saw that as soon as I went to compile. Here we go. So I compile that up. It takes it. Now I run it with just saying Java. And 100 is 100. I didn't lose. It didn't. Nothing weird happened. Why? Well, let's take a look at how these things get interpreted in actual binary. So here's what's going on. All right, we have binary. Binary is a 1 or a 0. And binary numbers are just made up of ones and zeros, however many it takes. Now, let's take a look at a byte, the byte data type. A byte data type is 8 bits, so 8 bits. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. To convert from binary to decimal, you take that number and consider it in the exponent, 2 to the power. We start with 0, so 2 to the 0, 2 to the 1, 2, 3, 4, 5, all the way to 7. So anything to the 0 power is 1, 2 to the 1 is 2, 4, etc. So let's take the number 100. The number 100 is represented as 0, 0, 1, 0, 0, 1, 1. And I added this extra 0, so you can see that it's a total of 8 bits. It's actually 7 because this is an insignificant 0, but it fits, okay? So 4, 32, and 64 is 100. So if we go back to the code here, okay, we can see that it's going to work because this is represented by 7 bits. A byte, it will fit into a byte perfectly, and therefore, I'll get my answer of this will equal 100. But let's take this a step further here, okay? Let me go ahead and let's redraw this. So let's do the bits. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is where a byte is. Okay, the data type of byte. This is the 7th one, so that's 2 to the 7th, or 128. So again, 1, 2, 3, 4, 5, 6, 7, 8. Look at this. I'm going to go ahead now and cross over. This is 256. Okay? So, let's see what happens. I'm going to come back into my application, and I'm going to change this 100 to 256. Now, this is clearly exceeding the limit of the byte because now I'm using an additional, the 9th bit. So if I save this and we compile demo 4, okay, it compiles here, and then I run it, notice how I will get 0. I get 0 because, let's go back into the slide here, because a byte it just doesn't know how to do it. It stops here. And that's what's meant by a complete loss of precision. You're losing the amount of bits you have accessible in order to create and work with your mathematical formulas. So in Java Fundamentals Part 2, we kind of continued along the path of learning the core language skills necessary to program in Java. And here we focused in on understanding the data types, declaring variables, working with operators and scope. As far as the data types, we went over the 8 primitives. Remember, nothing can be broken down beyond the primitive. So you had integer types like int, short, byte. You had Boolean for true, false. You had the floating point numbers of float and double. We talked about the rules and the syntax involved in declaring variables, like it has to start with a letter, an underscore, or a dollar sign. That's it. Operators in assignment, right now we showed you that the single equal sign is assignment. The double equal sign, we'll get into later on, can get confusing, but that's asking the question, is A the value of B? Variable scope, where am I declaring the variable? Is it a field at the class level or a local variable inside of a method? Looked at things like access modifiers, what the effect of public and private has on a variable, as well as the casting and the conversion, how I can take smaller data types and easily stick it into larger data types implicitly, but I will have to implicitly cast to take a large data type and stick it into a small data type. I hope you found this informative, and I'd like to thank you for viewing.